The pencil is the most popular writing instrument ever invented. They're used for drawing, painting, and marking all over the world. 6 billion pencils are made every year. But how do they get the lead inside the pencil? In this video we'll discover how Faber-Castell pencils are made. Pencil leads are made from graphite, a type of mineral coal made from deposits of prehistoric algae that have been buried for more than 400 million years, graphite is a mineral that started to be mined around 1564 when the first mine of this material was discovered in northern England, graphite is a form of coal. One of the softest minerals when you press it on paper. Very fine particles flake off and leave black marks. This material that pencils are made of is found deep in the earth and consists of crystallized coal-like diamond, but it's much softer. The first pencil makers used graphite taken directly from the mine, Pencils were created in 1795 by the Frenchman Nicolas Jacques Conti. His invention was based on combining graphite and clay, encapsulated in wood, both minerals, along with a bit of water, are mixed and spread through thin grooves, Officer Nicolas Conti came up with the clever idea of combining graphite powder with clay, plus taking it to the firing stage while pressing the same mass between two halves of cylindrical wood. And that's how the pencil we know today was born. Since the 19th century, leads have been made with a mixture of graphite and clay. Graphite is extracted from open pit quarries and underground mines like this one in Germany. It's very hard to find and even harder to bring to the surface. Miners use drill hammers to make holes for explosives. The mineral pieces must contain more than 30% graphite for mining to be profitable. At the end of the shift, the day's collection is brought to the surface. Once on the surface, the mineral is crushed into small pieces. The rock is crushed and turned into a fine, dry powder. It's now ready to be sent to the pencil factory. It belongs to one of the biggest pencil companies worldwide, the 200-plus-year-old German factory Faber-Castell. Once at the production plant, the raw materials used for the lead mixture are graphite, clay, and a bit of water. The amount of clay added to the lead mixture determines how hard or soft it will be. The amount of graphite determines how dark the pencil writes. Many people wonder how leads are put inside pencils. But in reality they're not put in. The creation process is a bit different from what we usually imagine, because making pencils is an art. To make the leads, the core of the pencils, manufacturers mix compounds like graphite and clay in a giant mixer. Then an appropriate amount of water is added and the machine starts beating all the ingredients. The paste has to rest for an hour and a half. This produces homogeneous granules. Colored pencil leads are made mostly with color pigments and a binding agent. When the mixture is ready, it's taken to a machine with funnels or molds where the lead gets its shape. The graphite and clay paste is stretched through a roller at very high pressure, almost 10 tons per square centimeter. Coming out, they look like the leads we use for writing. But at this stage the leads are still soft and flexible. To get them to that point they must be baked and then placed in a fryer with oil and melted wax. First they're dried at 120 degrees Celsius for 3 hours in an electric oven. To make the leads strong enough for use, they have to be baked for 45 minutes at about 1000 degrees Celsius. Colored pencils don't go through that treatment. High temperature would destroy the pigments. The wax bath gives pencils a silky surface. This way they harden and become as resistant as pencil leads. Because the more wax the mixture has, the harder and darker the lead level will be. The wax seals the pores of the lead, creating a surface that glides smoothly over paper. For good encasing. Wood soft enough to shape but strong enough not to bend in the writer's hand must be chosen, like cedar wood. For the pencil making process, cedar wood boards must be cut into rectangles, measuring 18 by 7 centimeters with a thickness of 5 millimeters. According to standard pencil measurements. Then the boards go through a wheel where grooves are cut that will hold the leads. Next they pass through a machine that fills the grooves with a special, slightly elastic substance called glue, which protects the lead so it doesn't risk breaking in the channel. This keeps the leads firmly attached in their wooden casing. The metal will places the leads one by one into their casings. The second wooden board is placed on top of the first. The result is commonly known as a sandwich. The sandwich is dried in an oven for almost an hour. Then a piston presses the boards using a weight of 1 ton for an hour so the glue dries completely. After this process, the sandwich-shaped boards will be so perfectly joined you won't notice they are 2 boards glued together. In the next step, the boards are passed through a machine called a milling cutter. This is probably one of the most important machines for pencil making because it cuts the wood to give it the proper shape, whether triangular, hexagonal, or cylindrical. About 10 pencils are cut from each wood sandwich. One person is in charge of testing quality by taking one pencil and sharpening it manually to check that the lead works. They must press the tip with a 2 kilograms weight, which it must withstand. Afterwards, the pencils get a protective coating. Each pencil receives several layers of paint for a perfect finish. Pencils must be painted about 4 or 5 times so the wood is well covered. The last lacquering stage, pencils go through seals the work with a transparent lacquer, also called varnish. The varnish is water-based and non-toxic because people usually have the habit of putting pencils in their mouth and biting them. After being covered with paint, pencils go through a stamping machine, which prints the code and brand of the respective industry at an impressive rate of 500 pencils per minute. When finished, the pencil must be painted separately by dipping it in paint. Sandpaper placed on an endless belt sharpens pencils much faster than a manual sharpener. To finish the manufacturing process, an eraser is placed on some pencils. The pencils go to a machine that first adds an aluminum ferrule and then attaches the eraser by pressing. A worker checks the pencils by hand. They're packed in boxes and distributed worldwide. That's how more than 180 million pencils are made each year. If you want to know how gold bars are made, you have the link in the description and in the.
Every year, more than 100 billion aluminum cans are produced. It is one of the most valued metals in the world. It bends like paper and resists like steel. It is used to preserve food and drinks. But how are millions of aluminum cans made? In this video, we will discover how Coca-Cola cans are made, from being recycled into huge rolls of aluminum to when the cans are filled. Every week, the world consumes the staggering number of 4 billion cans of soft drinks. Although it is almost everywhere today, aluminum was absolutely revolutionary when it was first used in the 1890s. 150 years ago, it was more expensive than gold. Carbonated drinks were not sold much in aluminum cans until the 1960s. But since then, cans have become so popular that Americans use more than 100 billion aluminum cans each year. About 45 billion cans are recycled in the United States each year, and more than 90% of this amount is turned into aluminum ingots used to make new beverage cans. This is the largest company in the world for recycling used beverage cans. They arrive from all over the world at their factory in England, compressed into bales that each weigh up to 1,000 kilograms and contain up to 65,000 aluminum cans. The aluminum can baler helps crush and compress loose cans into dense, uniformly sized blocks. The machine also wraps the solid blocks with strong thin wires. This keeps the cans together and makes them manageable and much easier to stack, load, and relocate. The blocks of compressed cans are loaded onto a conveyor belt and fed into a 340 horsepower shredder. Aluminum is difficult to sort because, unlike other metals, it cannot be separated with a magnet, so the shredded pieces pass through an optical sorter at a speed of 3 meters per second. The machine uses infrared sensors to sort what is metal and what is not. Aluminum contains contaminants like paint and lacquer. The clean aluminum pieces are ready for the next phase. 2 furnaces reach a scorching 730 degrees and each handle up to 100 tons of metal. When the aluminum melts, it reacts with the air, forming a layer of aluminum oxide that floats on top. This unwanted oxide is the slag. An operator removes it with a giant steel spatula. A river of molten metal flows downhill to a holding furnace the size of a double-decker bus. Somehow they need to pour the liquid metal into a mold. Inside, they will be melted into 3 imposing blocks of aluminum. Layer by layer, hot metal is added and quickly cooled with water. As it solidifies and becomes denser, it sinks further into the mold, allowing more aluminum to flow over it. After 2 hours, they have 3 giant aluminum ingots. Each one measures 10 meters long, weighs 27 tons, and is made from 1.5 million recycled cans. Today, the demand for aluminum is so high that the ingots do not stay there idle. Their transformation back into cans begins with a journey of 900 kilometers to a rolling mill. They are heated in another furnace to 525 degrees. This relaxes the bonds between the atoms, releasing any tension within the ingot. Then it is passed back and forth through a series of rollers. It's like stretching pizza dough. Each set of rollers reduces the metal until it is 1/4 millimeter thick and 10,000 meters long. With this, huge rolls of aluminum are formed and sent to Coca-Cola can factories. The supplier of Coca-Cola cans is a global producer of beverage containers. In this factory, containers are manufactured mainly for Coca-Cola beverages. It can reach 2,200 cans per minute. The cans start as huge rolls of aluminum weighing 9,000 kilograms. About 700,000 cans will come from each roll. The process for making the cans is highly automated. Once the rolls are loaded, they are spread into sheets. They insert the aluminum sheets into a rapid stamping press. This day press presses the metal more than 200 times per minute, creating the bases. Each time this press falls, 14 bases are created. The press will stamp a disc of 14 centimeters of diameter and then proceed to bend it into a cup shape. Everything that is left over is compacted and returned to the aluminum factory, where it will be recycled again to create new rolls of aluminum. A forklift takes them to a sort of resting area, from where they are distributed to the next machine. In that machine, the body of the can is made. Inside, a rod pushes the blanks through a series of increasingly smaller molds. Making the body of the can requires a lot of lubricant for the blanks to pass through these molds. It is vitally important that the machine is properly lubricated, otherwise, the aluminum could break when stretched. At the same time, this lubricant will also act as a coolant to prevent overheating. That's why the cans come out with so many greasy residues. Once we have the body made, a trimmer will clean and straighten the edges properly. After this, a conveyor belt will transport the cans upside down to the washer, where a cleaning process divided into 6 phases will be carried out. The cans enter the washing area to remove the oil. Part of the washing includes sulfuric acid. The cans are sprayed with a jet of ionized air. When the washing is finished, they are ultra clean and ready for filling. Each finished can weigh less than 15 grams. Each and every one is a pressure vessel. They must withstand almost 3 times the pressure of a car tire. The cans are now ready for stamping. This rotary printing system can apply up to 5 colors. Stamping the Coca-Cola logo on the cans begins with a kind of rubber mat that wraps around the cylinder. This cylinder is then installed in a machine called a decorator, a giant printer for cans. The main color that runs through this decorator is red. But those cans are not decorated with just any shade of red. It has to be Coca-Cola red. Then, the machine sprays a varnish inside the cans. This creates a barrier between the beverage and the aluminum so that the product does not end up tasting like metal. It also prevents the acid in carbonated drinks from corroding the aluminum from the inside. The cans then move to a machine that forms a 5 centimeter neck. The beater forms a curved edge at the top, where the tab piece will be attached. Now what they need is the top lid. This process occurs inside this machine at a speed of more than 2,000 cans per minute. Defective cans are immediately detected and sent for recycling. The finished cans will not spend much time in the warehouse. Many will be transported to the bottling plant, where they will begin their quick journey to the filling area. Subsequently, the cans enter the filling machine. A high-pressure carbonation machine introduces the gas into the non-effervescent syrup. The soda cans are cooled to 5 degrees to prevent the carbon dioxide effervescence from escaping the can. The machine's valves can fill 130 cans at once, at a speed of 1,700 cans per minute. The entire filling process is supervised by a single worker. It has an essential task: to ensure that the machine placing the lids never runs out of lids. Inside this machine, the lids are embedded in the cans. The factory must ensure that its customers receive a completely filled can. They use a gamma ray scanner. The cans that have not been sealed properly are set aside and recycled. At this point, the cans are at an ideal temperature for consumption. Inside a box, the cold cans could condense and wet the cardboard. So they are sprayed with water at 35 degrees to reach an appropriate temperature. After 12 minutes under hot water, the cans lose their icy temperature. When they come out, they are at about 27 degrees. Next, they have to dry the cans with air. Some cans end up in 6-packs held together by a plastic ring. Others end up in cardboard boxes. These cans will be part of a 12-pack. In 1 year, a can be recycled and sold up to 8